Hello, my name is Grace Pete, and in this lecture we're going to learn about relational design and data redundancy. Why are we covering this area or this topic? It's because we want to have skills and basic concepts on how to create a good database design. This will help a database designer or database developer to develop databases that do not have problem, do not have inconsistencies within the data, and a very good and a correct design of a database. Now, what is a data redundancy? Data redundancy occurs when the same piece of information or piece of data is duplicated in several places. Data redundancy causes many problems in maintaining consistency after updates of data in a database. So, what are the problems with data redundancy? Most common problems of data redundancy includes replication of data. Because you have replicated data, that means there is wastage of storage space within that system. It also brings about data anomalies. It also brings data inconsistency after update. In the next session, we are going to cover data anomalies. And this is a prerequisite for the next lecture of normalization. We have to understand data anomalies, and then we will understand better on how to normalize data to make data perfect for developing and implementing a database. So what are data anomalies? Data anomalies are inconsistencies in the data that is stored in a database. Such inconsistencies may arise when we have a particular record stored in multiple locations and not all of the copies are updated. There are three types of data anomalies. There is insertion anomaly, deletion anomaly, and update anomaly. Now, let us look at insertion anomaly. An insertion anomaly occurs when you're inserting inconsistent information into a database table or relation. This occurs when a certain attributes cannot be inserted without the presence of other attributes. Let us look at an example of a situation whereby you have insertion anomaly. Consider the table that you see there. It's a lecture course table where you have a lecture ID, you have a course number, you have a lecturer name, you also have course name and number of units. If you look at the records, at the data that we have in this table, you cannot insert a new course unless a lecturer is assigned to it. That's the way the table has been designed. It's a very poor database design. Another problem is you cannot insert a lecturer, a new record for a lecturer, unless he or she is assigned to a course, which brings about problem because you might be having a new lecturer who has been employed in that organization or institution and has not been assigned a course yet, but he needs to be in organization records. But for this kind of database design, you cannot insert or add his or her record unless he or she is assigned to a course, which brings about problem. Let us look at another example of insertion anomaly. We have a student course table whereby you have student ID, we have course number, we have student name, address, and a program. When you look at the records available in this data, first problem is that you cannot insert a new course unless there is a student who is enrolled to it. That brings about a problem because in an organization with academic institutions, we do curriculum review, we develop new curriculums, courses are developed every single day. So we cannot say you cannot add a new course unless there is a student who is assigned to it. Another problem is you cannot insert student details unless they are enrolled in a course. What about new students? Where will their records or data go? So that is a situation where you have insertion anomaly. Now let us look at update anomaly. Update anomaly occurs when one or more instances of duplicated data is updated, but not all. Update anomaly requires updates of data for every concerned row of data in that particular database. Let us look at update anomaly example where we have a table. This is an example for a bank account where you have account number, you have account name, you have account type, you have a branch number, and then you have a branch name. For example, if you want to update details of branch number 002, this is another branch, then you will have to update 3 rows in that particular database, which brings about problem. This is just an example of 5 rows in this table. But what if you have a big organization with 1,000 rows of records? How would you go into those records and update each and then look for a branch number 002? It might be having many clients. So this is a problem of update anomaly. Let us look at another example for update anomaly. We've got a table, a student table, where we've got a student number, student name, academic level, program number, and a program name. Let us see if you want to update the details of ICT program in this table. Then you have to update 2 rows in that database. As I said before, this is just an example. Maybe you have a very big database or a large table with 1,000 of records. You cannot go to each row and start updating that records you want to update. That is a problem of update anomaly. Let's look at another type of data anomaly called deletion anomaly. A deletion anomaly occurs when you delete a record that may contain attributes that should not be deleted. Let us look at another example of deletion anomaly. You have a table here for student, student name, academic level, program number, and a program name. For example, we want to delete student at row number 3. That means the details of that program for that student, this student was taking, will also be deleted, but that program may be needed by another student, or it may need it for record purposes. So this is it's not very good database design. It's a very poor database design. Let us look at another example of deletion anomaly. You've got account number, account name, account type, branch number, and a branch name with the 5 rows of records. For example, if you want to delete a record for that account number in row number 4, then the details of branch, Tabora branch, will also be deleted. But this is a back branch which records needs to be stored in a database. So this brings about deletion anomaly. So how do we avoid data anomalies in database design? Normalization is the procedure that removes data anomalies in database design, which brings about consistency in data, and there will be no data redundancy or replication of data. This is the end of our lecture on relational database design and data redundancy, where we've seen the problems that brings about data anomalies, which includes insertion anomaly, update anomaly, and deletion anomaly. Thank you for watching.